Consider a scenario. Pastor really is concerned about what might have happened to students whom have failed 4 modules first semester during exams. So he conducted the experiment to check if time, mind block, panic, lack of knowledge, and pressure were effects during the examination. Consider the following information. We are given the summary of the means for the treatment and the means for the block. So we have the grand mean, which is 71.75, but the mean for treatment 3 is unknown, it's x, and the mean for block 5 is unknown, it's y. So we'll have to calculate, and to do that, it means that we're going to sum the means of treatment, then we divide by 4, we'll equate it to the grand mean. We also do the same, we sum the means of blocks, we divide by 5, then we equate to the grand mean. Suppose you are given the sum squares of error, which is 21.8, required to construct ANOVA and test at 5% level of significance. So unknown values x and y are obtained by summing the treatment means divided by the number of treatment, and by summing the block means divided by the number of blocks, equating to the grand mean. So we'll get our x as 72.4 and our y as 68.5. So now that we know the mean of treatment 3, which is 72.4, and the mean of block 5, which is 68.5, we can first find the sum of squares of treatment and the sum of squares of blocks, since we have SSE, so that we can be able to construct our ANOVA. Then we'll test. So since we're using fixed effect model, the sum of estimated tau i's and the sum of estimated blocks are 0, where the estimated tau I is the difference between a mean per treatment and the grand mean, and the estimated block effect is the difference between the block mean and the grand mean. So the sum of squares of the block and the sum of squares of treatment are calculated as follows. Firstly, we'll need to find the estimated effect for each treatment and also for each block. So since we'll have to apply it in this one and this one, so that we can calculate these two values. For the estimated effect of treatment, since we're having 4 treatment, we have tau 1 hat, tau 2 hat, tau 3 hat, tau 4 hat, given by negative 1,15, negative 1,35, 0,65, and 0,85 respectively. Note that the summation of this estimated effect of treatment are equals to 0. If you can sum this, you'll get 0. So our SST is given by 5, then the summation from I equals to 1 to the number of treatments, which are 4, then of tau I hat squared, so which will be given by 12.95. If you take the number of blocks, which is 5, then you multiply by the sum of squares of the estimated effect, which means you are going to square this value, you square this value, you square this value, you square this value, you add them out, you multiply by 5, you'll get your SST. And as for effect of blocks, we have the estimated effect for block 1, which is 1.75, the estimated effect for block 2, which is negative 3.25. The estimated effect for block 3, which is 3.75. The estimated effect for block 4, which is 1. And the estimated effect for block 5, which is negative 3.25. And also note that if you add this estimated effect for these 5 blocks, you will get 0, since we said that the summation of the estimated effect of blocks has to be 0. So we'll get our sum of squares of blocks by T multiplied by the summation from J equals to 1 to the number of blocks, the estimated block effect squared. So our number of treatment is 4. So the summation from J equals to 1 to 5 of the estimated block squared. So which means, as we did with treatment effect, we're going to square these values first, then we sum them up. After we multiply by 4, we'll get our sum of squares for the blocks, which is given by 157. So now that we have our sum of squares of block, our sum of squares of treatment, and our sum of squares of error, we can find our sum of squares of total. Since we know that our sum of squares of total is just given by the sum of the 3, which is SST plus SSB plus SSE. So we'll obtain our sum of squares of total as 191.75. So at this moment, we are done with calculating what was required to be calculated. Then we are ready to go and test. We'll have to construct the ANOVA table. This is the ANOVA table with source of variations, which are the treatments, blocks, errors. Then we'll have the totals for these 3. We also have the degrees of freedom. So the degrees of freedom for treatment is given by T minus 1. Since the number of treatment there are 4, it means our degrees of freedom for treatment is 3. Also, the degrees of freedom for blocks is given by B minus 1. Since we have 5 blocks, so which means the degrees of freedom for the blocks is 4. And the degrees of freedom for the error is given by the product of T minus 1 and B minus 1, which is 12. And the degrees of freedom for the totals is given by BT minus 1, which is the same as 12 plus 4 plus 3, which I'll get 19. And as for sum of square, we calculated the values. Just to remind you, the sum of squares of treatment was 12.95, for blocks 157, for error 21.8, and for total 191.75. Now the mean square of error will be given by the sum of square of error divided by the degrees of freedom. So which means we're going to have MST, MSB, and MSE. For MST, I'll say SST divided by 3, which is the degrees of freedom for the treatment. I'll get 4.32. And for mean square of the blocks, I'll say 157 divided by 4. I'll get 39.25. Lastly, mean square of the error, I'm going to say 21.8 divided by 12, which is 1.82. Since I'm going to check that the effect of treatment are all equals to 0, or the treatment means are the same, and also to check if blocking was efficient, to check if the effect of the blocks are all equals to 0 or not. So I have two critical value F calculated. The first one that will help me to check the effect of treatment, and the other one will help me to check if blocking was efficient. So my F-cal for the effect of treatment is MST over MSE, which equals to 4.32 divided by 1.82, which is 2.374. And my F-cal for the block efficiency is MSB over MSE equals to 3.25 over 1.82, which is 21,566. Now, firstly, let's test for the effect of treatment. My null hypothesis will be the effect of the treatment are all the same equals to 0, or the treatment means are the same. And my alternative hypothesis will be at least one of the effect of the treatment is not equals to 0, or at least one of the means differ. So we'll have to check for the critical value from F table with level of significance of 5% and degrees of freedom 3 in the numerator, 12 in the denominator. So the value which I'm looking for is 3,490. As you can see, where your alpha is 0.05, which is 5% what we're looking for. So indeed, 3,490 is the correct value that we took from the table. So the next step will be comparing the F calculated with this critical value. So since our calculated value, which is 2.374, is less than our tabulated or critical value, which is 3,490, we fail to reject the null hypothesis. So what we're saying is there is no difference among the treatment mean, or the effect of treatment are all equals to 0. Therefore, our conclusion will be the means of the modules are the same at 5% level of significance. Remember, modules were referring to our treatment from the scenario. So let's also test if blocking was efficient. So my null hypothesis will be the effect of blocks are all equals to 0, or the block means are equal, and my alternative will be at least one of the bj is not equals to 0, or at least one of the block mean differ from the rest. So we also need a critical value from the F table at 5% level of significance with degrees of freedom of the block, which is 4, and of the error, which is 12. So the value we're looking for is the neighbor of the value we got before. So since now the degrees of freedom is 4 on the numerator, on the denominator is 12. So the value is this one, which is 3.259. So we'll also compare this critical value with our F-cal for the block efficiency, which, if I may recall, we found it to be 21.566. So if we can check if our F-cal is less than or greater than our F tabulated, we only to find out our F-cal is a bigger value, so which is going to imply that blocking was efficient. So we write it this way. Since F-cal is greater than F tabulated, we reject HO, the null hypothesis that the effect of the blocks are all the same equals to 0. We reject it. So we are saying at least one of the block mean differ from the rest. So if we reject HO, we accept H1. So, and we are going to conclude that blocking was effective at 5% level of significance.